Hello, everyone. I'm Radek, Team Ubisoft here to present you Hack the North Challenge from Hackers Nest, and also to give you a little bit of information about how our API works and what's the challenge this year. I'm excited to do it third year in a row. So our crowd is getting bigger every year that we are doing this. Obviously, this year things are a little bit different, especially considering the COVID situation and us doing all the hacking from home. But thankfully, the technology is helping us to be able to be with you all a little bit right now. I'm going to be streaming my my desktop just to show you guys what the API is all about and what the challenge is all about. And I really hope that you all are going to join us this year to try to make the best game ever for Ubisoft Challenge. The prizes are worth it. So without further ado, this is the link to our GitHub. This is where you get the source codes and the API itself. Whoever used GitHub in the past should be very familiar with that interface. If you aren't, you can always download the whole repository in a zip format and just extract it locally on your computer. And the first page is going to welcome you with what's the challenge this time around. The prize for the challenge, the prize for the winners is $500, as far as I know. And this year we want you to create the unknown. That's the subject of the challenge. But we also want you to include at least one mechanic from the list provided below. So you create whatever game you want to create. The topic is very open. But we want you to try to include at least one gimmick that we have here. So it has to be either a game that revolves around the mechanics that only use one button, or a game where the full gameplay loop should be finished and done within 60 seconds. We also have to keep it alive, a kind of an open-ended quirk here. 1v1, which kind of indicates sort of a PvP aspect of it. Everything's reversed, so winning is losing, losing is winning, for instance, or what else can you revert in a game? We also have one classical remark, which is Pong. So try to base your game on the most classical video game released to date, the first one to be ever released, actually. The more you have, the worse it is. That's the mechanic where like getting more scores or more coins or more gold makes your character heavier. Generally speaking, the more progress in the game, the harder it should get around you. So the idea is that your overall theme is whatever you prefer it to be. However, we would require you to include one of those quirks into your game. The other very important aspect, in order for us to have a fair competition and for everyone to have the same sort of starting and ending point, we do require you to use our API, and we do require you to use C++ as base engine. So even though you might be tempted to go like and try to do something in the game engine that you already know, like Unity or Unreal Engine, or like try to write something in Python or Java or whatever, unfortunately, we will not be looking into those submissions for the main competitions, because we want everyone to have the same sort of a baseline technology that they work with. So let me go ahead and go over some of the documents and some of the resources that you guys can use in order to make the game. So the first and most important, this is a click, and this gives you an information how to build and run the game. The supported platforms currently is Windows and Mac OS. For Windows, we would advise you to use Visual Studio Community Edition 2019. If you do have an older version of Visual Studio, you can use this little tip in order for it to work on the older versions. But straight out of the box, the API will work in Visual Studio 2019 straight out of the box. Probably the most important bit for you to look into, and something that I would like you to pay special attention to, is step-by-step tutorial. Step-by-step tutorial, the page that you're going to have on the GitHub is just going to be the first few sections of the step-by-step tutorial. If you want to see the full tutorial, the original link is at the bottom. It's going to get you to the Google Drive where the documentation is set. So this pretty much is like a wall of text, because there's like 60 pages of that, but please don't be afraid of it. Most of those pages, as you can see, are just code snippet and GIFs. So the actual text to learn is tiny, and this tutorial will walk you through starting with a blank API that doesn't have any functionality and going over the features that you might need in order to make a game that has collisions, the game that has animations, the game that has sounds, the game that has level editor, and the game that has a proper flow of the game that we are looking for. So just to show you what we are providing to you as a baseline, this is my Visual Studio with the API turned on. So one of the versions of the on the API on the GitHub that you're going to see here is called Flappy Bird. So this is Flappy Bird. It's just a simple game that we all know and hate. I personally hate. But this is just a simple implementation of our little birdie that is animated and trying to go around the obstacles. And the other project that we have here is called Blank. As the name suggests, the Blank project doesn't have anything. So if we run Blank, this is exactly what we expect to see, which is exactly nothing happening. To give you some idea why step-by-step tutorial is important, in my opinion, to do good at the challenge, at least to skim through it and to try to figure out how to read into it, is first of all, the step-by-step tutorial has all code examples here. You are allowed to use code examples from step-by-step tutorials, so your game does not have to start from blank. You can start by changing how the Flappy Bird works, or you can start from any of the steps that you're going to find in this Google Drive folder. The GitHub version is the only one that is fully supported by us and is going to be changed by us throughout the project if we find any bugs or any problems. But the step-by-step guide examples should work straight out of the box for Visual Studio setup. And to give you some idea what can be achieved with the API, let me show you the game that I made last year during the hackathon. I was hacking with the contestants. This was the game that I made as a birthday gift for my girlfriend. So I'm not sharing source code for that one because this one is supposed to have only one copy. But this is also the game that was made using the Hackers NEST API that you guys going to have access to. This is a simple Mario-esque type of a game. The main character is my girlfriend, Natman, and she likes playing pool. So you can pick up pool balls, you can throw the projectiles, you can attack enemies, jump platforms, collisions, backgrounds, everything is supported here. And step-by-step tutorial should provide you with every tool that you need to make this type of a game. Obviously, we don't want you to repeat exactly the types of the games that we did, and we want you to use your own creativity. But I want to give you some idea of how far can you get if you actually follow the step-by-step tutorial. And I think that from my side, the best way to showcase how the API works is to actually take it for a spin. So right now, what I'm starting here, it's a blank version of the game. So there's nothing in the game. And I'm going to try to show you how you can work with the API and how you can add your own stuff and how you can work from features. Everything that I'm going to be showing you right now is included in the first 2 steps of step-by-step tutorials. So whenever you feel lost, you can always go back to the documentation provided and try to look through those examples. We created it solely for the purpose of making it easy for you guys to work with our API. So let's start. The basic concept of our API is something called entity component concept. This is a pattern used in game programming in many, many other engines. And the pattern kind of goes like this. We have an entity. An entity is something that exists in our world, right? So entity needs to have, it's something that can be viewable on the screen, that exists in our game, that has certain position, certain size. But on its own, entity itself is not able to do pretty much anything. The whole idea is that on top of entities, we create components. And components are responsible for the functionalities that we want our entities to have. So one of those typical components that we're going to see in the examples is called render component. So render component is responsible for rendering the entity. Without render component, you will not be able to see entity on the screen. So we create those components and we attach them to entities, and that's the basic model. The other component could be like, for instance, keyboard movement that implements the functionality connected to us using the keyboard and being able to actually use the keyboard to move the character around. And that could be also attached to the entity. The other component that can be useful is, for instance, collision component. That allows our entity to work within the collision system. Why is that pattern important and why it's super useful in the games? Because in games, we create many different types of entities, and we want to avoid as much as possible duplicating the code. We want to write a piece of functionality that we are able to reuse across many different features. So imagine that this is our player, and our player would have collision component, render component, and keyboard movement, because we want our character to be able to be moved on screen, display, and be affected by collisions. So this is our player. And in a regular model, if we want to create another type of entity, which is, for instance, an AI entity, some sort of an entity, in a regular model of programming, we would have to then write the rendering for that entity separately. We would have to write all the other aspects of it separately. But because in the middle, we have those components that are doing heavy lifting for us, we don't have to do that. So for instance, we also have a component like AI brain that pretty much determines what our AI is supposed to be doing. Then the AI entity can use the same render component as the player used, but just with different parameters. We don't want keyboard movement component for AI entity because we don't want our keyboard presses to actually in any way interfere with the entity, but we might want it to be able to collide, and we might want it to have a brain. So this sort of a pattern is implemented solely for the purpose that we don't have to redevelop the wheel every time we try to add something new. What more we are looking at is like what pieces of functionality we already have and how we can reuse them in order to make something new. I hope it's all going to make a little bit more sense in practice. So let's go to coding. So this is our game board. Game board is a very good way to, game board is a very good class in our API where, to start doing stuff that is like the basic part of the game. As you can see, there are many other classes in our API already provided, even on the blank project. Those classes are usually divided between two namespaces, one of them being game and the other one being game engine. Game engine indicates that this class is connected to a little bit of more of a back-end engine that supports that entity component structure that I kind of tried to explain to you, and does some heavy lifting for you just so that you don't have to implement any low-level stuff in the game, but use the tools that we already provided you in the API, in those components already created for you, and use them to have the game working. So let's start with something simple. Since this is, again, a blank, so there's nothing happening here. Let's try to see something happening in that dark and sad black window. Font size. Let me try to figure out how I can do it. Is that better? That should be better. Okay. So let's start with something simple. So I'm going to add a new member here in the private section, and my member is going to be what I showed you before. It's going to be a pointer to an entity. I'm going to call it player. All right. With C++, a very good idea is whenever you add a new member is to initialize this member to some sort of default value at the beginning of the function. So in our case, this is going to be a constructor of the game. This is the first thing that happens when the game loads. The other thing that I'm going to need here, I'm going to put it here. I want to have a function that is going to be responsible for spawning set player, right? So I have a spawn player function declared in the header. And now let's write implementation for that. And let's see if it compiles. Things are happening. Okay, compile, step 1 done. So let's try doing something with an entity. So let's create a new entity. Just by using this. This is the first step of creating an entity. You just have to physically create it by calling it. After your entity is created, there's a very, very important step. The step is to register that entity inside our game engine. Without doing that step, our game engine is completely unaware that we've created something. So we need to do it in order for our game agent to be able to know that this is an entity that needs to be updated, that needs to be rendered, that things are needing to be happening to that entity. So in order to do that, you go to game engine main, get instance. This is a singleton type of a build. And there's a function called add entity. And let's add our player. As I told you before, entity doesn't have a lot of information without components. And this entity obviously doesn't have any components yet. But there are a few things that entity have by default. For instance, entity by default has position, which we can modify by set position. And let's just pass in a vector of 50 pixels, 50 pixels. So it's going to be in 50-50 pixel position XY axis. And entity can also have size. Let's do size the same size as the position, just to make things easier. And let's see how that looks. Well, as you can see, nothing really changed here, right? And the reason for that is we do have an entity there. I promise you, that entity actually exists there. The problem with that is, and I can prove it to you, because if I go to base entity class to its update function, right? And I'm going to put a breakpoint here so that the debugger will break whenever an entity updates. If I've done things correctly, it should break at one point or another. Oh. Not on the base class. Sorry, I'm looking at the wrong update. But the main problem that we're having here right now, okay. It's not going to do anything because I've created spawn player function, but I haven't called spawn player function. So we should probably call it from the constructor, right? Like if I create a function and not call it anywhere, it's not going to go anywhere. Let's see again if my test is gonna be working. Right now we are in blank. You can start working with Flappy Bird. It has pieces of functionality already implemented, but I want to start with blank just to show you guys how to start with nothing and go to something. So let's try that test again. I'm in entity, and let's see if update is gonna break. Let's hope it does. It does. So I put a breakpoint, the game stopped, and if I'm gonna press play, here continue, every single frame, a game loop logic goes over. This update is going to be called for the entity that we created. But we cannot really see anything on the screen right now because the entity does not have any sort of rendering component. So the screen doesn't even know how to render it. So the basic rendering component that we created for you guys already is called, it's a very weird name because it's called Game Engine Render Component. And the way to add it, the easiest way to add it is to just call player, add component. Here, let's pass the type of component. So what we've done with this line of code in particular, we told our entity that from now on, that entity should have a render component. And let's see what's going to happen now. Oh, Nothing is happening. Let's see what's going on. Player set position, player set size. Is being called. I actually was expecting to see something, but something obviously didn't work here. Let's see if a reboot is going to do anything. A little bit of technical difficulties is very usual while running this sort of stuff. I'm going back to the Flappy Bird just so that I know that my semantics is okay. Bear with me for 1 second. I think it might be connected to the error that I have here. Oh, okay, there we go. This is not going to happen on your side. If you follow my steps out of the box, it's going to work for you. I kind of messed with my own example and disabled a whole bunch of features before I started talking to you guys, which is always a bad idea to do just before presentations because then things like that happen. I'm holding my thumbs really, really hard. Yes, that green screen is a welcome sight. So now, why do we have a green screen here? The only thing that I've really done is I've added a component render component. So let's see what render component is actually doing. Render component has two functions, update and render, where render function is a function that is being called every frame and is responsible for rendering stuff. So let's see what's the implementation of that function. So that function grabs a render target. In our case, it's that little window that we have there. That's the render target that this function is getting. And what it's doing, it's creating a shape, a rectangle. It's setting the position of that rectangle read from the entity position that we defined here. Is setting the size of that rectangle based on the size that we defined here. And then sets a fill color from a parameter called fill color, and then draws the shape on the screen. So one thing that we do know from this, that there should be a way to change the color on the render component. And I see that there's a function called setFillColor, which is supposed to be doing that. So let's see how that works in practice. So whenever we add component, we return the pointer to set component back, just so that we can do stuff to that component, set up parameters and do other operations. So what I can do, having that knowledge, I can do game engine render component pointer render is equal to the player add component. Because whenever we add component, it creates the component, pushes to the entity, and returns the pointer. That's how this function works. Now, if I have that render component, what I can do is render set fill color. I need a color. Who's going to be first to chat to put in a color? Just so that it's true and not fake, right? Blue. All right, let's try blue. Yes, we have blue. Blue was the first one. Magenta is transparency. It's a weird color. We don't use magenta for real. All right, let's see if we're gonna be able to switch the color of the rectangle to blue. Perfect, right? So what we did here is we added the component that generally is done to draw squares, and then we just flipped the color on that component. You can specifically use RGB value, right? So you can use RGB value from 0 to 2.5. I think the implementation is not using hex because hexes are kind of not something that I see a lot in C++. I just tend to type a vector of 3 integers from 0 to 255, or 0 is black and 255 is maximum color. All right, let's move on. So we have our spawn player, right? But because you can see here that I'm assigning that entity to local variable here, I cannot really do a lot of stuff with it outside of this function, because if you understand how C++ works, that means that this thing is only created for the scope of that function, so it cannot be accessed anywhere outside. But as you remember, on the game board, I already added myself a pointer to a player that is a member, which means it's visible for the full class. So the only thing that I have to do right now is, instead of having this guy this, I can do, what's the name I did? No, lowercase. And just fix all those instances. Pro tip, in Visual Studio, if you hold Alt, you can actually do a selection like this. It's super useful if you keep your code clean. I think that's it. So now that entity is still created, but instead of just added to the value on the stack, it's added to the end player that we can actually do stuff with. So let's start doing stuff. This is an update function that should be called every frame of the game. So every time a game loop finishes and another one starts, this update is going to be called. So let's try something like this. Let's get the position of the player, the current one. So we do that by getting it like this. The same way as we can set position, we can get position. Now let's have some sort of speed. I'm going to set it to 5, because why not? And let's do position y. It's incremented by that speed in an update function. And just so that we don't lose the sight of the square falling down out of the screen, so out of the visible bonds, let's just do if position y is bigger than, let's say, 400, position y is 50, so that it goes down and then jumps up, goes down and then jumps back up. And let's make sure that we assign that position back to the player like this. So as you can see, it looks pretty glitchy, right? It just falls down the screen and it's super shaky. Does anyone have any idea why is that happening? You have approximately 15 seconds. Nope. Okay. The reason why it's happening is because, as I told you, update function is running every frame per second. When you think about games, you think that they have 30 frames per second, 45 frames per second. Our game is super simple, tiny 2D game that probably runs 300 or 400 frames per second, which means that 400 times each second we increment that position by 5, which means that the speed of that thing is completely uncontrollable. There is an easy way to fix that. We can take game engine main. To fix that, we need delta time. And the best way to get delta time is to get game engine main and get time delta. Time delta is the actual amount of seconds that passed from the last time the update function was called. And in this particular case, it's always going to be a tiny fraction of a second, 0.001 or 0.0002 or something like that. We have this colored because the header of my file doesn't have the, oh, I missed the namespace. That's the proper way of doing it. Yes, yes, okay. So that's how we have delta time. The only thing that we need to do with that delta time, well, is we need to, whenever we increment that position, we need to increment it by this times delta time. See what happens now. And now the square is super slow, because the actual speed right now means that it moves 5 pixels a second, and this screen is 400 pixels in height, so it's going to take it quite a few seconds to move all the way down. So this is how it goes. So we can just like change it to 150 and see how it goes through here. Unfortunately, usually we are able to go through more stuff throughout the workshop like that because we have an hour, but this time around, due to scheduling and things like that, we can only have half an hour. And I wanted to show you something that is actually working in the game engine and some sort of like techniques that you can add stuff here quickly. But again, in order for you to be even more familiar with what's happening here and how to go with it, please, oh please, go to the step-by-step tutorial. Because step-by-step tutorial is going to explain to you quite simply how to go from the step that I've created right now, from the moving square down, to the square that actually moves using keyboard inputs. So this is going to be, this is me changing the color here. So that's the part that I was doing. And this is the part where I explain how to use key presses to actually move the position of the square around the screen. Just to show you how that looks like from in Flappy Bird. It's something as simple as me creating a new component called, in my case, it was called player movement component. And we take the same sort of code where we grab the time delta, we figure out the, oh, there you go. We grab the time delta, we figure out some sort of a value pixels of a second, right? And now depending on the key that the user was pressing, whether or not it was left, right, up, and down, the only thing that we do is modify X or Y axis of that wanted velocity times that time delta to have the movement of the Flappy Bird up and down. And that's pretty much how this particular, oh, it stopped working for some reason. Did I added something here? Oh. Yeah, I actually started doing. I think I broke Flappy Bird when I was playing around. Oh yeah, it worked. So that's kind of what's happening here. I'm pressing arrow down and we're just moving the, oh, so unlucky 3 times in a row. I'm just pressing arrow down and we're just moving the Flappy Bird down, left, up, right. And that's the same sort of operation. I just take the position of the Flappy Bird, I multiply it by some sort of a speed and some sort of a time delta. And the only difference between the example here and the example that I showed you just a second ago is that this is not automatic, but this one is actually waiting for a key press on the user in order to determine whether or not to apply that velocity. I wish I had some more time to show you more things, but there's a good news here as well. We're near our booths all day today, all day tomorrow, and for the better part of Sunday. And if you want this sort of tutorials, or if you want to get this sort of knowledge from me, that's the best place to find me or other Ubisoft mentors who are as good with this engine as I am, to show you how to go over the problems that you want to have in your game. At the end of the day, we are expecting you to create some cool, 2D, stylish, nice game that fulfills your purpose of create the unknown, and more importantly, also implements the key. I think the prices are awesome. I think the challenge is pretty cool. The API was worked on for quite a while and seems to be working out of the box for most people. But if you run into any technical problems, you already know where to find me, and you already know where to find us. And I would like to wish all of you that want to try our API challenge and make a game with us, I want to wish you good luck, and I'm happy to have you trying out the challenge. You just run, yeah, the main CPP is the one that runs because it's the one that has the main function. The way like C++ works, that's the entry point of the application, if we are not talking about like Windows-based, window-like applications. So main CPP is what's gonna run. because main CPP is not really doing anything when you look at main CPP. The only thing that main CPP is doing is creating the game engine, and then the game engine kind of runs itself on the thread. I'm not sure if anyone is throwing me away from this room, or like, do I need to stop presenting? But if you guys have more questions, I'm more than happy to sit around with you for next few minutes and answer them. Yes. Again, go to GitHub, the one that is linked in the challenge. Let me just type it here. Here you're going to see step-by-step tutorial. And step-by-step tutorial on this page does only have the intro. But there is a full tutorial that has like 6 steps and ends with animation, collisions, level editor, and a whole bunch sounds and a whole bunch of other features. And that's the tutorial that I advise you to go through. This is a team effort. So the way I kind of saw people dealing with stuff like that in the past is that they divided labor into people who are trying to figure out what's the concept of the game and what they want to do. And some more technical people were in the meantime looking into documentation, playing with it, going through the examples with the examples here, and just trying their things. And also, very important thing that you have to remember is that if you click here, you can actually see examples from every step of the tutorial. So you can launch the example with level editor and have a working version of the game that already has level editor implemented. You are allowed to start your challenge with whatever source code we provide. So if you want to start with this version of the game, you are more welcome to do so. But again, it's going to be difficult for you to understand what's going on in here if you weren't going through the step-by-step tutorial. I think if we talk about general questions, I'm happy to answer you guys, but not on this workshop. Hop in booth. I'm gonna be by at my booth probably within half an hour or something. I just need to take a little break to have some coffee and some water. But I'll be more than happy to answer all of your questions that are not directly related to the API during that time. You're more than welcome to join us there. I'm not sure if you're all aware how to get there, but it's going to be like on hopping. It's going to be on the sponsors bay. You just go to the Ubisoft booth. You're going to have some people from recruitment there who can tell you a little bit more about the internship opportunities and things we do with this part of Ubisoft. So if you are interested in internship or co-ops or stuff like that, you're going to have recruitment people there to help you out. And there's also going to be people like me who are nerds, programmers, who are going to be able to talk to you about all the nitty-gritty technical details that you might run into with your API, or that you might want to know just in general about game development. And one thing that is very important to me, I will not care. I do not care, and I forget every question when it comes to judging. So do not be afraid to ask questions. Do not be afraid to approach us. Right? This will not impact your judgment and the final score at the end of the day at all. And also, it's easier for us if you show us work in progress. You don't have to surprise us at the end. Our job is to let you guys create the best game that you can do during this challenge. That's my only purpose here. And if you do, you're gonna win the challenge, regardless of how many times you approached us during the competition. I just want to stress it out because there were some teams in the past that were approaching us often, and some teams in the past that tried to keep on the down low and just surprise us at the end with their project. I do feel that teams that approach us often have easier time finishing their projects, whereas those who try to work on problems on their own, they sometimes get stuck for longer than they have to. So please don't be afraid to contact us, and please don't be afraid to talk to us. Visual Studio Code, no, we didn't test it on Visual Studio Code. I think it should work because there's nothing there that I can think of that specifically is preventing it from working. No, Visual Studio is a dedicated platform. If you have Visual Studio 2019 Community Edition, the GitHub should work straight out of the box. If you have any other edition, you might have to retarget the solution. There's here on the GitHub, you have a note from my friend Kevin who tells you how to do that. If you go to build and run, this is the part that helps you with build and run. And you have to go to Ubi Game Properties, General Platform Toolset, and change it to the Visual Studio version that you're working with. So you should be able to use whatever Visual Studio you are using. The version that you see on my desk is Visual Studio 2017, and I had to retarget the versions, and it worked fine. Yes, you can contact us on Discord. However, there's a lot of chat rooms, a lot of things happening. So I think Discord is a good place to contact me. But I will prefer face-to-face or some sort of like a camera chat room for most of the questions, because we also don't have time typing all the answers. Sometimes it's just easier to go over for things by voice, especially if we talk about issues that you might have specifically with the challenge itself or your game itself. If you're trying to find me on Discord, that's my Discord handle. It's not my full name. And there are also other programmers on our case. We have also Evan, who's been speaking in this chat a lot. There's also Xavier, and there's also Nikhil. I think all of them are present in the chat. If someone can say hello from Ubisoft just so that your names are visible, that'd be great. Well, you can try to export the game into WebGL, but I'm not sure. Like, the problem with it is that the game itself uses a library underneath it to draw images on the screen and to play sound called SFLM. It's a super fast free media library or something like that. The code of the game itself is going to work because it's a pretty basic code that should run on whatever is running C++. However, I think you might struggle with the libraries that our engine is using in the backend to draw stuff. I think this is something that's going to be a problem. And to be honest, like we would probably prefer a standalone XDA applications. Like, I don't think it's super important for us for it to be on WebGL, unless this is like some bigger picture that you have in mind. Then you can try it, but it's not something that I personally would be able to help you with. It's not something that's my area of expertise, to be honest. It should work, but I'm not sure about the libraries that we use. Like, this is something, if you know that SFLM is working on WebGL, then you might be okay. But other than that, like, I wouldn't waste more than 2-3 hours on trying that. And if it fails, just keep to the standalone application. That's my advice here. Do we have anyone else who wants to ask something? Let me double check that. I think it's SFLM, SFML. Yep, SFML, Simple Fast Multimedia Library. Just a pro tip, if you guys are doing any sort of like a 2D project or something like that, this is a pretty cool library because it does a lot of heavy lifting on drawing shapes, drawing sprite, drawing textures. It's something that we normally have to kind of type in manually as programmers, and it's just a waste of time most of the time, because like it's not a difficult or like especially sophisticated programming. It's just the grunts work that you need to put in and just like type in a lot of code to be able to even see a window, or to be able to draw a rectangle on the window, or to have a camera. The SFML kind of gets that back by default. You will recognize whenever we use SFML, because it's very specific. for instance, that vector is part of the library because it has this SF at the beginning of the name. And for instance, if we go to the key presses that I kind of was showing you before. So for instance, this whole SF keyboard is key pressed. That's not a function that I wrote. That's not a function that we wrote at Ubisoft. It's a function that we got for free just because we use that SFML keyboard library in the background. So that's how you recognize those spots in the code that are referring to the original library that exists underneath the code that we've done. Okay, I think this is it. I don't see any more questions here immediately. As I mentioned before, I should be at the booth in a few minutes. Myself, I think there are going to be people there already that are waiting for you and your questions. Happy coding, good luck, and try to make something awesome. I know, like, creativity here is the real limit, and 24 hours, and technology that is difficult. But there are limits. There are limits. Okay, let's agree there are limits. But you're gonna be all right. Have a good luck. See ya.